Can I start now?
Yes, sir. Yes,
Hello.
sir. You can start. Yes, sir. You can start.
Okay, good morning, everyone. Today I'm going to speak to you people on hot and cold weather concreting. The organizers are once again QCrete India Private Limited, and this is their 10th webinar and mine 5th webinar. One little correction I would like to show you on the slide is that my email ID is ending with .com, gmail.com. So that is missing. Well, this is a very interesting topic where I will be talking to you both about the hot weather concreting, the difficulties, the solutions, and cold weather concreting also, the difficulties and solutions. In our life, we come across not only in concrete, but in our life also hot weather and cold weather. And we have to handle both. Concrete is like our better half. When hot, it needs cooling, and when cold, it needs warmth. I remember when we had to do our massive pours at the Trombay Thermal Power Station, and it was nearly summer, coming close to the monsoons, and the temperatures were very high. We had to use ice flakes. You can see on the photograph on the right hand side, and on the left hand side you see the photograph with my dear wife standing in front of the batching mixing plant, and the snow is covering the aggregate stand. Of course, there was a tarpaulin put in between because we would not like snow to contaminate the aggregates in the cold weather conditions. This photograph was in Tashkent, where I had the opportunity to do a little bit of cold weather concreting. We talk about hot weather now. First, I will cover hot weather. What is the definition of hot weather? High ambient temperatures, high concrete temperatures, low relative humidity, high wind velocity, high solar radiation. Hot weather is any combination of the above which impairs quality of fresh or hardened concrete and or cause detrimental results. So it is a combination of the environment, the temperature, the humidity, the wind, and solar radiation. We are often under the wrong impression that hot weather means only temperature. No, as per the Canadian standards and as per several other international standards, the temperature of concrete is to be maintained as per the chart, also depending on the thickness of the concrete section which you are going to do. For example, if you are having less than 0.3 meter thickness, you can do concrete between minimum 10 degrees to maximum 35 degrees. If the section increases further from 0.3 to 1 meter, you can do concrete with minimum 10 degrees and maximum 30 degrees. If the section is from 1 to 2 meter, then you do minimum 5 and maximum 25. And if the thickness is more than 2 meters, You can go as low as 5 degrees centigrade temperature as minimum and 20 degrees as maximum. So really speaking, the concrete temperatures can be varied between 5 degrees centigrade to 35 degrees centigrade, depending on the thickness of the member you are concreting. It's not just temperature of the ambience. In hot weather, if you are doing pump concreting, you have to be extremely careful that there is fluidity in the mix. There are no delays, and as far as possible, no stoppages in it. Hot weather concrete problem generally occurs during the summer season, obviously because temperatures are high. Thermal shrinkage is more severe in spring and fall due to the temperature differential. So one has to take care of thermal shrinkage whenever you do concreting in spring and fall. When air temperatures are identical, a calm, humid day is less severe than a dry, windy, sunny day. Why? Because in a calm, humid day, there is not much of an environmental change, but in a dry, windy, and sunny day, there are more actions of wind and drying elements like sunshine, etc., and therefore it could be more severe. I generally compare a human being with concrete, and especially in hot weather concrete. In hot weather, the human being would like to drink more water. So
Hello, sir. Your voice is not audible.
my mic is now on. In between
Okay.
it is summer here in Mumbai, so even the webinar gets heated up and needs to be treated and put on. Now you see some few photographs. I would like to show you this slide where a transit mixer is lowering the concrete through its chute. In hot weather, one has to be careful. The minimum slump which can be unloaded by a transit mixer without the input of manpower is about 50 millimeter. And if it goes less than that, then you need people to drag the mix from the chute. So this is one of my own observation when we did concreting at various places in the Bombay Thermal Power Project using transit mixers. There are two ways of measuring the temperature. One is the one which you see, a thermometer type of an arrangement, which is showing 37.2 degrees centigrade. And the other is a probe type of an arrangement where you put the probe in the concrete itself and take the reading on the dial gauge, which is seen. And it's very easy to measure the temperature of materials as well as temperature of concrete using this probe type measuring instrument for the temperature. Increased difficulty in controlling entrained air content. Now this air entrainment is necessary in cold weather, not much in the hot weather, so you don't have to worry. We hardly use air entraining agents in hot weather. decreased 28-day strengths and later strengths. This is a very important thing to note. Concrete behaves slightly differently. And if I give an analogy, in the hot weather, it gains strength very fast and has higher strengths at 1 day, 3 days, etc. And the strengths at 28 days are lower than what we anticipate. I would compare concrete here with an athlete who generally runs 100 meters. So he has to go fast, he has to have a good start, and he has to have also a good finish to win the race. In cold climatic conditions, the athlete is a marathon runner. He runs slowly and steadily and gathers speed at the end. So when you are doing cold weather concreting, the 28-day strength improves considerably than what you had measured at 1 day. And also, there are good chances of concrete strength increasing even after 28 days, maybe even after 56 days or more. High water demand and concrete temperatures have to be monitored properly, and one has to ensure that the water to cement ratio does not get haywire or increase unnecessarily due to higher water demand. Now, this is an interesting graph which you see here. I will compare the 28 days and 1 day strength in 20 degrees centigrade concrete and also in the 40 degrees centigrade. Now, if you see here, in cold climate, the 1 day strength is lower, 20 degrees, you get about 6.9, but good and substantial increase takes place, and the 28 days concrete result is very good, 41.8. If you go to 40 degrees centigrade concrete, you get very good strength at 1 day, 13.8, and not so good strength at 28 days, 34.5. So one has to remember that whatever we are calculating or anticipating based on 1 day results, in hot climate, you won't get the satisfactory results at 28 days. So one has to make sure that proper cement addition is there, and if necessary, you can cool your concrete with ice flakes, etc. Effect of ambient temperature on setting time. It is quite common and understandable that in hot weather, the concrete sets faster because cement hydrates faster. The materials are hot, and therefore cement also starts hydrating faster. Concrete stiffens faster, resulting in poor compaction or lesser time for initial setting as compared to concrete done in cold weather. And formation of cold joints, there are good chances in hot weather if we are not timing our pouring sequence properly. So one has to plan the pouring sequence so such that after the first layer is completed, when you are doing the second layer of concrete over it, the needle vibrator should go right into the bottom layer which had been done earlier, and compaction takes place in both the layers, the lower layer and the top layer, the new layer, the fresh layer which you have put, and therefore one gets proper jointing between the two concrete layers. If your vibrating gang is a little relaxed and the pump operator is not attentive, there are good chances that the vibration will not be done properly and concrete will. Okay, again the audio connection got disconnected. Now it is okay now. Concrete stiffens faster in hot climate and therefore heaps up. So you have to be very careful. You unnecessarily put concentrated load when you are doing slab construction, and you need to spread the concrete or you need to slow down the pumping rate, etc. Honeycombing, entrap air, all these problems will come if your vibration is not done properly of the concrete. So one has to plan the way you will be vibrating, sufficient number of needle vibrators, etc. will be required, and also you have to be careful that concrete does not heat up. Talking about the coal joints, which I told you, here you can see a sketch where the operator is lowering the needle right past the fresh layer and it goes slightly into the lower layer. So you have to be sure that the lower layer is not set hard. Otherwise, you will get a coal joint like this. You can see here. Coal joint very seldom influences the strength, but it will definitely influence the durability of the concrete. Because when there are temperature variations later on, the coal joint is likely to allow more water to penetrate into the concrete and damage the steel by way of corrosion. In hot weather concreting, you slowly, quickly put in the needle vibrator and then slowly withdraw it, making sure that when the vibrator goes out of the upper layer, it does not make a hole-like impression. Otherwise, it means that the concrete is hardening faster than you expect. Many a times people avoid putting the end stopper, and ultimately the workers stop the concrete and don't vibrate the end of the concrete, resulting in poor vibration and honeycombing, which is very, very harmful as far as durability of the concrete is concerned. Increased rate of setting is obviously, as I told you, resulting in difficult handling, finishing, and risk of a cold. In hot weather, these are the problems. The other problem is also the increase of the plastic shrinkage crack. I remember this is one of the most important things, and there are lots of misunderstanding between the consumers, the cement manufacturers, and the RMC manufacturers. The consumer often feels that we sell cement with cracks, or we sell concrete with cracks, and therefore the slab cracks. The concrete cracks due to rapid drying conditions on the surface, and it is very, very clearly visible, especially when you are doing slab concrete. High ambient temperatures, wind, and low humidity are the enemies of concrete in hot weather. So the concrete surface has to be properly protected. Immediately on rendering the slab, cover the surface with a plastic sheet. Make sure that the entire surface of concrete is properly covered. Otherwise, there will be evaporation of the water when concrete is still in a plastic stage. When concrete is in plastic stage, mind you, it does not have any strength. It is like a newborn child. It has to be properly protected. Now this, you can see here, the plastic shrinkage cracks have occurred on the top and have penetrated through the slab. They come right through, bypass the reinforcement, and definitely they will be harmful at a later stage because they will be allowing the water, the rainwater, the seepage, etc. to occur through and through the slab and cause corrosion. So this is the best method. Put plastic sheet, cover it proper, cover the slab properly as soon as you can. Some engineers are reluctant to put plastic sheet because they say that the surface will not come out properly. However, I can tell you that surface really does not matter on the top because afterwards you are going to do waterproofing or you are going to do tiling and covering the top surface of the concrete. But cracks will definitely be much more harmful to concrete. Always make sure that the plastic sheet is weighted down, put some weight on it so that if there is wind, it does not blow away the sheet. Another alternative is you can fog or spray fine mist on the concrete surface if you are not having or if you are reluctant to put plastic sheet. But it should be continuous till concrete has gained enough strength. Otherwise, you will get plastic shrinkage crack because concrete has remained plastic and can easily crack. And now I can show you that the soffit of the slab is crack free. This was demonstrated at one of the sites in Gujarat where the client objected that the cement supply was with cracks, etc. And to his surprise, when we put the plastic sheet and cured the concrete properly, there were no cracks visible, no through cracks, even after ponding water on the top surface. When people do big constructions, especially the bridges, decks, etc., they take great care. Mind you, there is a little difference between a plastic sheet and a hessian cloth. Generally, we used to put our open up the gunny bags and put them because
Hello? Sir, it's not audible, sir.
high concrete placing and curing temperatures results in reduction in final compressive strength. And the other side x-axis is the age of test. One can see I'm very sorry. This is the lockdown problem of the courier service. Okay, I continue further. And if you see here, these four curves are there. The temperature 23 degrees centigrade is the lowest. So it starts with a lower strength and goes higher and higher, overtakes the other strengths. 49 degrees is the hottest concrete, which is not very recommended to do. Then there is a concrete done at 40 degrees and concrete done at 32 degrees. So all these four curves are there. One day, definitely the hot concrete will be overtaking everything. Then we go down to 3 days and 7 days. Again, the 23-degree concrete crosses the 49-degree concrete and gains a better strength later on, and so on and so forth. But it is generally, we have observed that the concrete with higher temperatures will have lower strength at 28 days as compared to concrete done at lower temperatures. Potential problems in hot weather: increased drying, shrinkage, and thermal cracking. Now, plastic shrinkage occurs when concrete is still plastic. Drying shrinkage occurs after concrete has hardened. And if the curing is not done properly, or there are several other reasons, when the concrete starts cracking and the cracks become wider and wider after the concrete has hardened. And then what happens? It allows the moisture, the chemicals from outside to go into the concrete. The corrosion happens. When corrosion happens, the bars, due to the rust formation, increase in volume. They give tremendous tension within the concrete and concrete starts cracking. Also, as the temperature inside the concrete increases, there is a thermal differential between the concrete and the ambient temperature, and therefore again thermal cracking can also take place in hot weather. This cracking business reduces the durability of concrete. It may not structurally initially harm the concrete strength, but later on, yes. An increased potential of reinforcement steel corrosion due to increased cracking and permeability becomes a nightmare for the people staying in the buildings like this. This is a very important thing. Many a times when we were conducting our mixed design workshops in Ambuja Cement, this question used to come repeatedly. Drop in concrete due to slow reduction in free water. Drop in workability. It can occur because if your aggregate is dry, it can absorb the water, and the water which is used in addition to hydration of cement while doing concreting is sucked in, and the workability drop suddenly takes place. This can happen more severely if there is more porosity in the aggregate. But mind you, which we generally use basalt or granite as a concrete aggregate in India, the 2% moisture absorption means 2% of the water can considerably influence the lowering of the workability of concrete. Further, six one nine six four six. Hello. Can you hear me now? Hello, Aishwarya?
Yes, sir. Yes, sir.
Sorry, this courier business is a big headache. Evaporation loss takes place and the water starts leaving the concrete surface. When concrete is still being placed or handled and the temperature of the ingredients also go higher because of the removal of water, or the mix becomes more stiffer. However, one thing is there, a very important thing one must do is spray the aggregates with water before they are used in concrete. Of course, your water to cement ratio may increase, but making allowance for that water in your water to cement ratio, you can comfortably adjust the little bit of extra cement content and allow the water on the surface to evaporate. The evaporation we have learned in the school causes cooling. So that is one way beneficial to concrete also. And especially in high ambient temperatures, this evaporation could be faster, but it will go on cooling the aggregate which is on the top surface of the concrete. Evaporational loss is again a very important factor to be considered when you are doing concreting. Other most important thing is cement hydration. In hot climatic conditions, depending on the fineness, the physical property of cement, if the fineness is very high, the cement will set faster and concrete will harden faster. Chemically, if the C3A content of the cement is high, the concrete will harden faster, it will generate more heat, and it could be harmful to the concrete if the hydration of the cement is much faster than envisaged. Temperature of the ingredients also plays a very important role, because what happens is that if the temperature of the ingredients is higher, the cement also will hydrate faster. because cement is all mixed in it, and therefore these are the very, very important factors one has to bear in mind. On this photograph, you can see people have put the aggregates. This is an RMC plant in Nasik. They have covered it with a shade, and also they are spraying water which cools the aggregate, and this aggregate goes into the batching mixing plant and produces concrete in hot weather. The other place here you can see the pipeline which utilizes concrete. In summer, we cover the pipeline here with a Hessian cloth. Why Hessian cloth? Because you have to continuously keep the Hessian wet, and when the water evaporates, the pipe cools, and the concrete inside is also in a cooler environment than in a hot summer environment. And this helps in pumping. Concrete remains fluid for a longer period of time. And this photograph is taken from in Middle East, where concrete is being supplied in transit mixers, the ready mix concrete. It has got a nice hood on the top, which has an air insulation between the drum and the hood as the truck moves, and keeps the drum inside cool, which contains concrete, which also, in other words, you can say concrete also remains cool for some time within the transit mixers. So these are all precautions which are necessary to avoid absorption, evaporational loss, and cement hydration during the concreting in hot weather. The usual way to control concrete temperature is to control the temperature of each ingredient. The temperature of freshly mixed concrete is related to the temperature of concrete, specific heat, and quantity of each material. Like for example, aggregate is the maximum quantity which we use in the mix, and therefore temperature of aggregate is also very, very vital. Now, if you see this particular formula which we use to determine the temperature of concrete in hot weather, so one must know the temperature of aggregates, temperature of cement, temperature of water, and temperature of the water on the surface of the aggregate. Similarly, one must know the amount, the mass of aggregate, the mass of concrete, the mass of water, and the mass of moisture on the aggregate surface. So if you know all these, you can determine temperature of concrete. Indirectly saying that
Hello. Sir, it's not audible, sir. Hello. Yes.
placed at 23 degrees centigrade. So we had made such a mix, so that the temperature goes down at 23 degrees. Because we were doing this concrete, we had anticipated was about say 38 degrees centigrade to 40 degrees the setting time of the concrete when the temperatures was around 40 degrees, would we say 2 hours? But on that day when we were doing concreting, the temperature shot up by 2 more degrees. It went to 42 degrees and the setting time reduced to about 30 minutes. So just a few degrees centigrade increase in the ambient temperature can play havoc with your concrete when you do the massive pour. So immediately we had to put more flake ties, add a retarder which will slow down the concrete setting and continue the work. You can see here crushed ties was being used. The Mumbai Metro also did a very good job and they had relatively slimmer sections of the beams, etc. But they had recommended 30 degrees centigrade for placing of concrete. So they had a contract with an ice manufacturer who gave them this ice crusher. This roller rolls and the spikes crush the aggregates. And the consistency of the crushed ice is just like crushed powder. A very small granules of ice flakes come out, which are collected, heaped and put on the conveyor and added as per the mix design of the quantity of ice to be put, flaked ice to be put. So this was done in Mumbai Metro. You can see the sections are not very large, but the specifications were as per the international standards. And the good thing they did was they ensured that the concrete was put, all concreting was done at 30 degrees centigrade for all the precast members. The first metro, Mumbai Metro, which was constructed by Simplex Infrastructure. The owners were Reliance and MMRDA. And the grade of concrete was M50. This is an excellent chart which gives you some idea of what actually happens when concrete with flaked ice is used, especially because of that. You can see the mass of all the materials, cement, water, aggregates, ice, etc. In the second column, we see the specific heat. And in the third column, we have column 1 into 2, column 3, giving the joules to vary temperature per degree centigrade of concrete. Then the initial temperature of the material is given in column 4. And if you multiply column 3 and 4, you get the total joules required. And if you take the total joules required divided by per degree centigrade, you will get what will be the temperature of your material. Now, one thing interesting to note is that if you are adding ice, ice contributes 0 degrees temperature, so it contributes nothing. It affects the cooling. And also, when the ice melts, it imparts almost minus 14,740 joules reduction in cooling, and therefore the temperature of the concrete comes down to 23.9, which otherwise would have been much higher if the ice would not have been there. So the basic idea of putting ice flakes is that the ice must melt in concrete while you are placing and compacting, so that it imparts the maximum cooling effect on concrete. Concreting, the control of aggregates, the temperature is very, very important because 70 to 80% of the mix constitutes aggregates. and they are generally black in color. They are hot if they are not stored properly in shady areas, and also simple methods are available to cool the aggregates. Stockpiles should be shaded from sun and kept moist by sprinkling water. Storage bins should be painted white or light colored so that they reflect the heat. They don't cause problems. By means of refrigeration in dams, if you are constructing dams with very massive concrete and a lot of control, then you refrigerate your aggregates. It goes through a conveyor and refrigeration takes place, so they are very cold. Immersed aggregates in cold water, which is a very difficult process. Cooled air circulation in storage bins, that can be tried out. Vacuum cooling when reduced aggregate temperature as low as 6 degrees. Now sometimes massive concrete of dams, etc., the concrete temperature has to go down as low as 6 degrees centigrade, and at that time you have to bring down the aggregate temperature to as low as 1 degree. So sometimes they use vacuum cooling of the aggregate. This is a view of one of the batching mixing plants owned by RMC India Limited, and you can see the color of the silos silver and the transit mixers painted white, etc. So they do not absorb the heat. Even the transportation of the aggregate, which is done using a conveyor, all covered shaded areas are used, and of course most of the transit mixers are white. I remember one of the RMX concrete, not the RMC company, a new company had come in and they had put their transit mixers on the road with black paint on. So it does a reverse effect. Probably white color gets dirty because of the spilling of the concrete, etc. So they thought that it would be better if they paint the transit mixers black. So I can imagine in Mumbai heat, how much of heat absorption would have gone into the concrete and how much of slump drop would have taken place. But later on they switched on to some different color of the transit mixers. Cement. Temperature of cement does not usually contribute significantly to the temperature of fresh concrete, but you have to take care when you do the mix design so that you put minimum possible cement. Cement has low specific heat, almost as much as the aggregates, and even the silos should be painted in such a way that there is a reflective color to avoid temperature rise of cement. Factory fresh cement should not be used. Cement should be used after it has cooled down to about 60 or 70 degrees centigrade. Some of the manufacturers, concrete manufacturers, use a MIC, that is fly ash and slag addition, or sometimes use Portland slag cement and Portland fly ash cement. But generally, due to the cost, they are always comfortable with addition of fly ash and slag as a mineral admixture in concrete. But one has to ensure that the customers have to ensure that this fly ash or slag they are adding is as per the Bureau of Indian Standard requirement in concrete, not just any fly ash or any slag which comes out of the thermal power station or comes out of a steel plant. The addition of MIC slows down both the rate of slump loss and setting, provides additional time for placing and finishing, And in some cases, the rate of bleeding can be slower than the rate of evaporation, so plastic shrinkage cracking will reduce or the crazing will reduce. So these are all the methods used. Admixtures. Admixtures do not replace appropriate technique of cooling concrete constituents, nor those for transporting, placing, and curing. If you add an admixture, it improves the workability without adding extra water, improves the slump retention, or retards setting, especially in hot weather. So this is very, very important. It does not cool down any ingredient. It improves the workability, and you can add less cement if you are using an admixture, and also have better slump retention and retard setting if you are using these admixtures. Before preparation in hot weather, you must ensure that all equipment handling like mixers, chutes, belts, etc. are all properly covered, and the transit mixers sometimes are covered with a burlap like a Hessian cloth and kept wet when they are transporting the concrete in it, so that the drum gets cooled and the concrete inside also remains cool. Solar radiation is also reduced. Forms, reinforcement steel, subgrade should be fogged or sprinkled with cool water just before concreting is placed, so that the concrete, the water in the concrete does not evaporate and cause rapid setting of the cement. For slab on grade or slab on ground, it is a good practice to moisten the subgrade the evening before concreting, so that the aggregate, the subgrade is cool enough. Avoid ponding of the water or standing water in the pits. Just sprinkle the water so that just before the concreting operation start, the aggregate are surface dry or the concrete is surface dry. Or you can restrict concrete placement by either using early hours or late evenings or nighttime hours. Less thermal shrinkage, cracking of thick slabs and pavement take place when concreting is done in late hours in the evening or throughout the night. Now, this was done when we did the TG decks, because they were round the clock, 24 hours. It is being done now in many of the foundations of high-rise buildings in Mumbai, where it is advantageous because traffic is less and concrete can travel faster to the sites. But sometimes there are road restrictions. If you are doing concreting in residential area, and you may not be allowed to do late night or round the clock concreting, but certainly precautions have to be taken so that the temperature of the concrete is controlled properly, especially in very massive pours. Transfer
Hello. So it's not audible again.
transporting. It will be interesting for you people. Now it is worked. It will be interesting to note that should you get a choke in the pipe due to concrete stiffening, then you go on banging the pipe, and where you get the hollow sound, you know that just before it is the plug of concrete. So you can open that plug and clean the pipe. This is because the concrete has lost its workability, proper care was not taken, and pipes were not properly protected, or there was a delay and they could not open the pipe, etc. So now they have to remove the plug. The other way concrete can jam your pipe is by segregation of the mix. Now when concrete is pumped, there is a lot of pressure, and if the mix is not cohesive enough, it will segregate. And once the concrete segregates, the finer material is consumed because it is segregated, it has gone out of the coarser material, and you will get a honeycomb type of a plug which has jammed the pipe. So in your future mixes, you have to be careful. Concrete has to have good workability and also lesser chances of hardening should take place in case of stoppages. What is advised is that you should always have the hopper of the pump full of concrete. And when there is a stoppage, maybe due to delay in transportation or maybe due to some choke somewhere, or vibration gangs are not efficient enough, etc., then the concreting or the pumping of the concrete slows down. So the operator must be told of the concrete pump to give one stroke every 15 minutes to half an hour, so that the friction between the pipe and the concrete inside is broken every time. Because if you are going to start the pump after the entire delay has been taken care of, then there are chances that the mix will stiffen inside and refuse to be pumped, and your entire operation can stop. So this is a very, very important thing. Many a times with the enthusiasm of doing the work fast, people empty the entire hopper of the pump. And sometimes the air enters the pipeline and you get an airlock and the pipe chokes. So one has to keep the concrete level in the pump up to the bottom of the grating at least, to take care of all these eventualities. Temporary shades, windbreakers like they were using in the Bombay-Pune expressway, but this was rather kept too high. This was only to keep the operators cool rather than concrete cool. Then the windbreakers in high-rise buildings, very important to keep the wind away from the concrete surface. And of course, when you are floating the slab, the floating should be done promptly after the water sheen disappears from the surface, or when the concrete can support the finishers. It means the weight of the finishing equipment may be manually done or may be done with the equipment or mechanized concreting. Retaining form in place is no substitute for adequate curing. Curing needs to be done immediately, as concrete is leveled and continue for the specified period. If moist curing cannot be continued, concrete surface should be protected for drying and using heat reflecting plastic sheets, curing paper and curing compounds. So this is very, very important. Curing and protection. Curing compound can be used on horizontal surfaces. Should be applied immediately after the final finishing as early as possible. But when you are doing high performance concrete, curing compounds should not be used initially. It should be preceded by 24 hours to 72 hours of wet curing, and then you can use the curing compound on the surface. Abroad, they use aliphatic alcohol to reduce evaporation when normal curing is not possible. But it is dangerous to use in India. We have seen, because alcohol is favorite of the construction workers and they may consume it before using it for concrete. Fogging, curing paper and curing compound are used on concrete roads, flat surfaces which are exposed to the ambient climatic conditions, etc. Mass concrete is best cured with water. This provides additional cooling benefits in warm weather. Curing should be continuous for 14 days if cementitious materials are used in concrete or in cement. Liquid membrane. Some of the curing compounds are wax based and they adhere to the concrete surface. If it is roads, if it is in the joints, the construction joints don't come out properly, so they have to be sandblasted and removed. If their adherence is not visible, then it is okay. Otherwise, yes, you will have to use some methods to remove the membrane. Here you can see a large dam being constructed and Asian cloth, plastic sheets, all combinations are being used for curing of the concrete. Plastic shrinkage, as per the ACI 305R-91 nomograph, which most of us used in hot weather concreting. The critical value as per the Canadian code is 0.7 kg per meter square per hour, means the evaporation taking place at the rate of 0.75 kg per square meter per hour is safe. As per Australian, 0.5 kg per meter square per hour, the value is safe. You will not get plastic shrinkage cracks. Otherwise, you will get plastic shrinkage cracks if the value exceeds, depends on which code you are following. The American code is silent about this particular factor, but it states that the combination of temperature and relative humidity should be between 41 degrees to 90 and 90% of humidity, 35 degrees and 70%, or 24 degrees and 30%. But I would rather follow the nomograph, which is also showing that the concrete will depend on the the temperature, and plastic shrinkage will depend on the relative humidity, the concrete temperature, and the wind speed at the time of concreting. If you see here one example, if you are working at, say, 60% humidity, and concrete temperature is 30 degrees. The wind velocity is say 5 kilometers per hour. Then you land up with safe parameter, so plastic shrinkage will not occur. But if you increase the temperature at the same humidity, the concrete temperature is 35 degrees and the wind is more, 15 kilometers per hour, then you just about all make it to 0.7 kg per meter square per hour. And generally under the Indian conditions, we have to take care of the plastic shrinkage because our humidity will be high, especially in the coastal areas, but in the interiors of India, it will be dry and low. The concrete temperatures would be always higher than 35 degrees because we seldom use flake ties or cold water. And of course, the wind speed will also maybe at times higher, especially if you are nearing the monsoon period, it may go much higher and cause plastic shrinkage cracks. Now we go down a very brief talk on the cold weather climate. From hot weather, here the sheep has removed the wool, so it is wondering what has happened to my hot weather. It has suddenly become cold. In cold weather conditions, some animals survive comfortably. It's not because they have covering on their body of wool or hair, but the polar bear especially, it is noted that the solar radiation on the skin of the polar bear is arrested on the hair and it gives static electricity which heats up the body and protects the body. Same thing is true for the yaks and maybe a little bit true for the sheep. Concreting in cold weather. Well, accidentally I happened to travel from Zurich to Innsbruck and back on the same day, and that was the heaviest snowfall I witnessed. Of course, I was in the train most of the time and on the station rest of the time. It was the heaviest snowfall and the trains got blocked because there was an avalanche just outside the Albro tunnel. But the efficiency of the Swiss railway, they removed the blockage and I could return back to Zurich. But the scene outside, I have taken this photograph from the hot climate of my coaches of the railway. Well, my experience in cold weather concreting came during the cold weather. And you can see here is our team, a delegation which had gone to Tashkent to hold the first meeting before starting the hotel project. In warm weather, the workers enjoy the pleasant climate of 20 degrees or 25 degrees, etc. of Tashkent. And you can see they are all normally dressed, but once the cold weather started, they are all clothed with jackets and woolens. Workers make a difference between success and failure. And when the weather conditions are harsh, they make more difference. You should have strong workers who can withstand the cold climatic conditions or even the hot weather conditions. Now, Tashkent had summers which could go even up to 41 degrees centigrade and winters which can go as harsh as minus 15 degrees centigrade. But Moscow in USSR will be always 20 degrees cooler than Tashkent, whether in summer or in winter. but we were not doing construction in Moscow, we were doing in Tashkent. And the weather conditions in the worst case would look like this. This was somewhere in the December of 1988. Our first concreting was done somewhere around November, and the president of Uzbekistan was invited to inaugurate. He came along with the first secretary of the Tashkent City Party, as well as the deputy chairman of the Council of Ministers, along with our Consul General. They inaugurated the first concrete. And of course, Russia does lots of concrete work, so they were seldom aware of pumped concrete being used. And when the president and all the VIPs come, they come along with their folk dancers. And to our surprise, the folk dancers were dancing to the tune of Raj Kapoor movies of Sangam, etc. And they were really very beautiful. And the boys enjoyed it before inaugurating the concreting work. Concreting can be placed comfortably in winter conditions if precautions are taken. 1.5 minutes. Concreting can be placed, definition of cold weather, again, it's very important. ACI 306 says 3 successive days with average temperature below 5 degrees and stays below 10 degrees for 12 hours, then it is called cold weather concrete. But our specification said that below 5 degrees centigrade, don't do concrete. All devices, materials needed for adequate protection and curing must be on hand before concrete placement is commenced. Very important. Effect of low temperature. Significant drop in strength can occur if the water inside the concrete freezes. So you must remember that the minimum strength of concrete, 3.5 megapascal compressive strength, should be achieved within a few hours of concreting. Otherwise, the water inside the concrete will start freezing and cause enormous drop in strength. Setting time increases, delaying the concrete finishing. One thing is good that when concrete we are doing is at about say 20 degrees, 15 degrees, very comfortable for a human being also. With a sweater you can withstand that temperature, and very comfortable for concrete also. There are no hardships of setting or vibrating concrete. It flows very well through the concrete pumps, and bleeding water takes longer to evaporate, so lesser are the chances of plastic shrinkage crack on the surface. Concrete takes longer to harden and gain strength. Delay formwork removal sometimes, so that is a disadvantage if you want to repeatedly use your formwork. And when concrete freezes, you get a design like this. Ice crystal formation occurs as unhardened concrete freezes. So one has to ensure that 3.5 megapascal strength is achieved by the concrete. I will go a little faster. Another advantage we got in during the winter was not slow slump loss occurs, and therefore we could do longer stretches of pipeline. We went to a maximum of 300 meters. Of course, now the world record is more than a few kilometers, and concreting was pumped beautifully without any problem. Generally, equipment should not pose a serious problem in conditions up to minus 15 degrees Celsius. because the electronic fissures and the hydraulic oil do not freeze up to -15 degrees centigrade. Recommended temperatures are given in this chart for different weather conditions. More than -1 degree, between -18 and -1 degree, and less than -18 degrees. The thickness again plays a very important role in concreting in cold weather also, just as in hot weather. And you can see at -1 degree centigrade, the temperatures can be 16 degrees of concrete and 7 degrees if the massive pour is there. But I can tell you at -1 degree to get 16 degrees centigrade concrete temperature is extremely difficult. Manageable is about, say, 7 to 10 degrees centigrade. Minimum temperature of fresh concrete as placed and maintained for smaller sections, 13 degrees. Again, very difficult to achieve when the ambient temperature falls below 0 and goes only to 5 degrees centigrade. That is okay, achievable when you are doing massive pours. Even 7 degrees to some extent is achievable. There is no advantage in using fresh concrete temperature greater than 21 degrees. You are unnecessary, there will be greater rate of heat loss, increase in thermal cracking after hardening, and plastic shrinkage can occur. Requires more mixing water for the same slump, so that is bad for such strength. Concrete temperatures while mixing should not be more than 6 degrees above the minimum recommended range. More than 5 degrees. Okay. Admixtures. The most commonly used admixtures for offsetting the effect of cold weather concreting is addition of a set accelerating admixture, which we used to call anti-freeze admixture, or in the local language vodka, because admixture increases the rate at which the cement hydrates and thereby increasing the temperature and strength development, so that is advantageous. We had a local admixture given to us which was nothing but sodium nitrite. Later on, when we brought it to India and tested it, we found out it was only sodium nitrite, and that was lowering the freezing point of water in concrete. That was the fundamental role it was playing. Interaction with air entrained admixtures and coal chloride content, we should be careful. Their use should be approached with caution whenever you are using air entraining and chloride based admixtures. Not recommended now. Hot water can store 5 times as much of heat as can cement and aggregates. Naturally, the specific heat is higher. Freezing temperature is seldom necessary to heat the aggregates. Below freezing temperature, often only the sand needs to be heated, which we did not do because we were doing just one experiment we did at 0 degrees centigrade with a foundation of 2 meter thick. So we were happy with the 10-degree temperature of the concrete, which we could achieve. Water temperature should never exceed 70 degrees. We were lucky that in Tashkent at the batching plant itself, we were getting cold water supply, which was of course in winter at 0 degrees, and hot water supply, which was in winter at 60 degrees. So we could mix the hot and cold water and get a mix of 30 degrees when we did that concreting at nearly 0 degrees centigrade. Care should be taken to ensure consistency in temperature of concrete delivered to the site. Ensure adequate supply of hot water. Mix water and aggregates before adding the cement, because aggregates will again increase the temperature of these water, and there will be less chances of the mixed water being very hot before cement is added. Otherwise, fresh set of the cement can take place. In general, composite cement tend to gain strength more slowly than the normal OPC in cold climatic conditions. What I suspect was the cement supplied to us was big and cement. So it was a blended cement. It was better than OPC at times, and in hot weather conditions it was very good, but even in cold weather we could manage with the same cement. Hardening or higher strength gain can be achieved if you use OPC, which we call OPC is now cement grade 1, 52.5 strength, or type 3 cement. Increasing cement content, any type, will be advantageous in cold weather. Use of low water to cement in concrete and low slump. Now, when we are doing mixed design for the concrete, we have to be careful about the water and concrete temperature. The mixing water temperature is shown on the y-axis, and the weighted average of aggregate and cement is shown on the x-axis. And if you want to do concreting, the temperature of mixing water needed to produce heated concrete required for the required temperature is shown on the different curves or straight lines, you can say. So if you want 8 degrees, if you want 12 degrees, 16 degrees, 20 degrees, what should be the temperature of the water and what should be the weighted average of the aggregate and cement temperatures. Aggregate protection is very important. It should be covered like we showed you the earlier photograph where complete cover was there, and everyday exercise, remove the snow which falls in the night, and then remove the sheets and then start concreting. Use of insulated foam and protective cover will protect the concrete from freezing at least until it has commenced to harden and gain strength. One very interesting factor we noticed was when we were doing the foundations, the raft foundations of the hotel building, and later after the concreting was done, we were covering it with insulated sheets, and the snowfall would take place in the night, and snow will collect on the insulated sheets. But so much was the heat generated by the concrete, even through the insulated sheet, the snow used to melt. And only after 3 days or 7 days of concreting, mainly 7 days of concreting, the snow was allowed to collect or would collect on the insulated sheet, because the hydration of the cement would go slower, and this was an indication that curing is no longer required and we could remove the sheets. Timber form work is reasonably adequate protection. Heated formwork also can be employed, but we have not used all such things in our hotel project. Heated enclosures were also not used. This type of insulation was not given because it was not necessary. Our temperature conditions were very clear, 7 degrees, don't go below that. Once we went, and the consultant took some objections, but which was later on overruled by the senior management because of the precautions which we had taken during that single pour at 0 degrees centigrade. Windbreaker again is a very important aspect both in hot and cold weather concreting. Insulated column formwork is also available, but that is if we are doing in a very minus 40 degrees or 50 degrees environment. Insulated concrete form also is available, or hydraulic system with a hose to defrost the subgrade and warming the formwork can be used, but we have not used this. Curing concrete retained in form or covered with insulating sheet seldom loses enough moisture at 5 degrees to 15 degrees to impair curing. Curing does take place when the insulated formwork is also used. When formwork is removed, the concrete should be covered with plastic film or waterproofing tarpaulin, just as we showed you in the hot weather. However, moist curing is needed to offset the drying from low winter humidity and heater used in enclosures during cold weather. No, we did not use any heating this thing because most of our massive pours were done just around winter, and we had the insulations, we had covered them with blanket, and we could get adequate strength also of the concrete without any difficulty. Stripping of formwork. Vertical formwork may be removed when concrete has reached the strength of to resist the frost at 3 megapascal. However, delay stripping of formwork as long as possible. You can delay, accelerate the hardening, avoid thermal cracks, temperature variation within a member. This is to monitor and fortunately for us all the sections were after the last truck-mounted pumps successfully operated for 6,000 experiments done in Vienna. Just I wanted to show you in new climate wind tunnel at 25 degrees centigrade in the month of September. They did this experiment 2007 and operated the truck-mounted placer boom machine at minus 15 degrees centigrade environment, and it could work beautifully without any problem. The steel structure of the equipment, the electronics and the hydraulics proved that it could operate even at minus 25 degrees centigrade. But if you go beyond minus 25 degrees centigrade, then it's a different story. Even the pump operator has to stand on a platform which is heated from the bottom, because otherwise he will also get frozen at that temperature. And the entire equipment is encased in a much insulated manner where a human being can survive as well as the equipment. But up to minus 25 degrees, this equipment can withstand. I thank Shelly Fernandez, Managing Director of QCrete Limited, for giving me this opportunity. And I also thank Kaushik and Ashwarya for giving me support for all the webinars we have conducted so far. This is the 5th one. If there are any questions, please do not hesitate to forward them to Shelly SF2013@gmail.com. They will be answered by email subsequently by Shelly in his team, and some of them by me also. Thank you, ladies and gentlemen. I thank my wife for guiding and keeping behind me to make sure that I deliver the lecture within the slot available. Participants, for your valuable presence and good wishes. Thank you all. Okay, over to
Thanks
you.
a lot. Thanks a lot, Dodi sir.
Thank you.
This, I think, in my 30 years, one of the very, very unique presentation in my 30 years experience I have heard actually.
Good.
I can say it is for any concrete technologist, it is a delight to hear from the view of technical points, whatever you have presented actually. And it also underlined the difficulties which you faced and the vast experience you could able to bring it on when especially cold weather concreting was done, and even some cases of hot weather concreting. And I can say it is really a kind of a reference manual for engineers and people working with concrete. And of course, I thank you also for taking us to Tashkent in this COVID crisis situation. Actually, thanks a lot. Thanks
Thank
a
you
lot.
very much.
I also thank all the participants for hearing this beautiful lecture by Mr. CM Dodi sir. I'm sure you have all appreciated the finer points, the technical points, especially the points which have been underlined for the cold weather concreting, which you are not at all exposed to actually. Probably we don't have that kind of temperatures here in India to do such works actually, and this is really a very, very unique presentation. Thanks a lot, Dodi sir, again. And I also thank our MD Shelly Fernandez for organizing this presentation. Thanks a lot. Thank you.
Thank you, everyone. Bye.